There is another way of testing the input and the output of the gap generator. And I want to show that to you now. Set the amplification to 125. Scroll over here. Get this in the center. Okay, we're in neutralization mode. A DC in, DC out. Input volts and amps measured to coil side of the relay. And outputs to the same two 1500 watt heating elements and two forklift lights. Now we're in neutralization mode, and the watts over unity is 105.66. But see this amperage in here, the maximum amps input to the first half of the cycle, 58.4. But it has an average of 6.95. Now the difference with this test is a capacitor. And with a capacitor, I have to run it on a 15 amp fuse. And I cannot use a capacitor and run this thing in amplification and neutralization mode. If I do, it will blow the relay contacts to smithereens. It'll just weld them shut and everything else. So let me show you a picture of the capacitor. Yeah, this guy gave me this capacitor and said if I would put this on this device, that it would increase the output by quite a lot. So I tried it. Now here you see the capacitor here in blue and the white and the black wire coming from in here. And coming over here to a full wave bridge rectifier. And I have the black wire here, the positive, hooked to the positive output on that rectifier. And the white wire is hooked to the negative output of that rectifier. And here's the capacitor just sitting in front of the two coils. Now, one thing I should say right now is I'm only using one coil in these tests. Not both coils, just the one on the left is the only one that's being used. And I think I have another picture of this. Yeah, here's the capacitor standing up between those coils. It's a rather large capacitor, in my opinion. I don't know much about capacitors. So, anyway, so much for the capacitor. Now, this is as recorded. Now I'm going to bring up the file that shows the last half of the input removed, because we are in neutralization mode and there's no power being applied. Now here is the now the watts over unity is 178.81. And again, this is the same test. I've just removed the second half of the input. And we still have the 58.4. I want to show you the schematic here for this thing. And here it is. Here's the battery or battery bank or the power supply that I'm using now. Here's the relay. And here's the coil and with the magnets attached. Here's the rectifier, full wave bridge rectifier, and here is the capacitor. And here's the load. We'll blow this up here a little bit, see if we can't get this in here a little better. Can't really, but anyway, you can see a little bit better there. And we'll move it from side to side here. Anyway, that's the schematic. Now, Let's look at the scope. Now here is what the oscilloscope looks like. Number one is the volts input. It's the yellow. Number two is the amperage input. And let's bring it up here a little bit. Notice how it goes way high. I have that, let me move that up a little bit here. I think you can see it a little better now. Anyway, I have, see how the amperage comes. Let me just take this to this screen. This showing one cycle. Okay, this will be a little better. Let me take it back just a hat there. Right here's the start of the cycle, and it's 60 milliseconds long, the cycle is. 30 milliseconds, half the cycle. So here's 10, 20, 30. This is half the cycle. And then 40, 50, 60 right here. That's the end of the cycle. So power is being applied for the first half of the cycle. But at the second half of the cycle, it goes negative. And it's showing it being applied here, the voltage. And here's the amperage. See, it shoots all the way up to 20, 40, almost 60 at 58.4. Bounces back down here and then shoots back up. Then it comes down gradually to zero, or near zero. Comes over here to the halfway point and goes negative here. Down to around probably 10 amps, and then works its way back up to somewhat less than zero. But note the output, the 3 here, the purple is the voltage output, and it never goes negative. It's always positive because there is AC and DC on this device, and that's why I'm converting everything to DC on the output. So this is set to 20 volts. So here we got 20, maybe around 37 volts or so, over here to the halfway point, 30 milliseconds, and then it'll fall back down to around 10, thereabouts, at the end. And in the amperage, it starts off, I've got that set to 10 here, so it starts off around 7, comes up to a little over 10, looks like. Let's bring that up here. A little over 10. Comes on over here to midpoint, starts downward, and comes down to about 7 again right here at the end. So, anyway, that's what the scope looks like. Now, I can set this, my amp probe, where I'm checking this, to, let me get another picture here. Let me go through these cat 1 to 2 here, and yeah, right here. This picture right here. I have my amp probe down here on this wire, checking the input amps here. But see this opening right here on that black wire, that opening? I put my amp probe on that wire, and I'd get that same look as on this scope here. Let's see. I get this same look. I get that whether it's at the coil side or it's on that capacitor. Same thing. Kind of strange to me, but I don't know anything about capacitors. And but if what that guy told me is true, And that capacitor is having this kind of effect on this device. This is really something, in my opinion.